Good afternoon, everybody. Welcome to the Squared Up Coffee Break webinar on Advanced Application Availability Monitoring. My name is Matthew Long, and today I'm joined by our Support Test and Systems Manager, Adam Kinniburgh.
Hi there.
So we're going to take you through today sort of a deep dive into our Enterprise Application Availability Monitoring. I'm actually going to show you this, a bit of sort of peeling back the layers a bit, showing you how we use the feature to monitor squareup.com and all of its sort of subsidiary subdomains using EAs. May not surprise you, we're a dashboarding company. We have lots of all screens on the office with lots of dashboards on, so we thought we'd talk you through that a bit. So discussion points today are going to be looking at availability tests under the covers, so a real deep dive into how they've been implemented in SCOM. Looking at changing the default out-the-box behavior for web tests, so a couple of examples and scenarios there. And then finally, looking at using the Custom PowerShell option with a pretty typical use case, we suspect, of monitoring a critical site or critical app from lots of different places and aggregating the results together. So hopefully a lot of content and a lot to get through. Spoilers, we might overrun slightly, but I'm guessing you're all probably used to me doing that by now.
Yep.
So let's get straight started. Okay, so very quickly, just in case you haven't seen it, the use case here of availability monitoring in EAs is to make the typical sort of outside-in user-facing availability monitoring for business apps really easy without you having to go and configure manager pack and have specific like SCOM and authoring knowledge. So the idea is you just pick which test type you want, and we support 3 out the box. You specify the response time of how quickly you want that test to complete. You choose a group which contains servers that are acting basically as watchers. It's up to you how many of those you have and where they are. So you pick where you want your test to execute from, and then it aggregates the results of that and gives you a nice nice sort of red-green for the whole app about whether users can access this thing or not. The idea is it's not supposed to replace like advanced monitoring that you might already have via third-party management packs or SCOM's own transaction monitoring features. It's supposed to be just there to make it quick and easy to configure a quick check and actually really get going with doing application monitoring rather than infrastructure monitoring. So that was the sort of idea. Right now, you have to be a SCOM admin to be able to edit and create EAs. So that is sort of one thing to bear in mind, but we are investigating some self-service scenarios. And if you want to use credentials as part of these tests, which you often will, you need to configure run as profiles in SCOM to be able to handle that because you don't want to be exposing those in plain text to people. Okay, so just in case you haven't seen the feature, I'm going to do a very quick demo, but this also forms the basis of then sort of what we're going to be discussing for the next sort of 35 minutes. So it's worth just quickly checking this out. So I'm over here inside Squared Up. If I go to my enterprise applications and hit the plus button to create a new EA, I'm sure you've seen this demo before by now, but if I go into the sales app, give the EA a name, so my application is the sales application. I go to configure availability monitoring and turn this on. You'll have simple URL monitoring, TCP monitoring, and then if you've got an EAM Plus license, you'll have custom PowerShell monitoring. So if I pick URL monitoring, it just asks me for what URL do you want me to monitor? So sales.squaredup.com. If you want to match on a particular text string that has to appear, or conversely, if you know you've got friendly error pages where technically the response from the web page is actually that it's a success, but the content of the page says there's been an error, you can put that in there and say it mustn't match this to be considered up. And then finally, you have some response time measurements. If you want to, you can say, okay, the page has to come back within a certain amount of time, otherwise we consider the app to be down. Because, for example, if the app takes 10 seconds to load, your end users probably consider that app to be down if every single page takes 10 seconds to show up. And then the final thing is to choose where you test the thing from. So here you can pick the default availability test clients, which in our environment, that group's got our management servers in, or we can pick from various different groups that we've configured with servers around the Squared Up estate. So in the cloud, here in UK HQ in Maidenhead, or also some specific to a certain particular application like squareup.com here. Once you then hit save, this will be saved in, and then we can produce lovely dashboards like this, where we can show all of our different apps and their relative health state over the past 24 hours or whatever, attach SLAs, all that kind of good stuff.
So I guess one of the key features to highlight there is you haven't at any point talked about infrastructure or dependencies. This is just application availability tests. And that's, again, a pretty exciting feature for a lot of customers.
Right, exactly. It really should be end user focused, and those test clients should really be as close to end users as possible. Don't test it from the server. If you test it from the server itself and there's a network segmentation fault, okay, great. The test will keep passing, but no one can get to the app.
Yeah.
So it really is important to be testing from nice and close to the end users. Ideally, if you've got like a campus, if you're a university, have a test machine in every building. Because then when one building fails and all the rest are up, probably means that's a building that's having an issue. And you can say to users, look, just go to a different building, it'll work fine, rather than having to work out, is the app down for them or just for certain use cases? Or is it partially down somewhere else? How close to the server is the fault? That kind of thing.
Yeah, exactly.
Cool. Okay. So that's sort of the feature at a high level. Now, that's all very well and good. We've done some magical stuff in the UI there. What's actually happened under the covers? So inside SCOM, when we've done that, what's happened, if you peel back the layers there for a second, see nice cheesy animation. When we created the sales app, what happened was a group was created called the Sales App Availability Monitors. So it's EA name Availability Monitors. And that group will contain our tests. You then pick a test group. And when you do that, you pick some servers. They may have tests running for other applications as well. So in the example here, these two test servers have got some PowerShell tests and some TCP tests running already from other applications. And then our management pack creates, or rather the EAM feature, uses some stuff in the library management pack to create web test instances, and it puts them inside that group. So if I were to go to the SCOM console now, I would find a group called Sales App Availability Monitors, and inside that group, I would find 2 instances of a URL test, one for each of my test servers. If my group contained 11 servers, I get 11 instances. And then what all those classes actually have is they have a monitor attached to them that runs a PowerShell script. And that PowerShell script is what's used to measure app availability. The only difference between like a URL test, a TCP test, and a custom PowerShell test fundamentally is actually the script that gets run. And in the case of a custom PowerShell test, the script is the script you give us. Otherwise, we've got a script out of the box that's run for URL tests and TCP port tests. And the configuration that you specify is passed in as a second parameter to that monitor that says, okay, this is how quickly it has to respond. This is the URL they want to test and the content they want to match for, all that kind of stuff. Now, because this is all monitor configuration, that means that it's all overridable. So if you want to modify the behavior of these tests, you can do so using all of the extreme depth and power that SCOM overrides provide you. And if I go on to the next slide, you'll see that this is really, really flexible. So let's say I've got 4 enterprise applications configured here. They have a bunch of different test nodes, and they have various different numbers of tests, depending on the nodes. There's actually a slight error here. There should be 3 servers in each of these 2, but my PowerPoint isn't quite up to date, so sorry about that. Each of these contains a group that's got a whole bunch of test instances underneath it. Now, I could create an override targeting the web test class. And if I do that, that means I'll modify the behavior of all web tests, regardless of which application they're actually in. So this could be a good way of modifying the behavior of all URL tests and saying, actually, I want them all to behave slightly differently in our enterprise. And I'll talk about that slightly in a moment. Or I could do a group override. So I could say for this particular EA, I want its tests to behave differently than every other EA's tests do. And I could do that for every single application if I wanted to, so I could get quite granular there with customizing the behavior of certain apps. Or I could do a watcher-specific override. So I could say all the tests that execute on this server, multiple EAs are all using this server as a watcher class, but actually, maybe it's further away, it's in our DR site, it needs a higher latency than other apps would, so give it a few extra seconds to respond to kind of take advantage of the fact that it's on a slow link. Or maybe it has an alternate proxy it has to go through compared to everything else, so this node should use a different configuration for that. So that's quite flexible as well. And then finally, you have an instance-specific override where you can say, actually, just this one test in this one particular EA, this is how it should behave, which again could be used for like environmental requirements, so it's different from all of the others' peers. And you can layer these as well, using, again, SCOM's existing override hierarchy. Quick piece of trivia, Adam. Do you know how many different rules there are for how overrides get priority and which one overlaps?
No.
9. There's 9 different steps to that. So if you're not familiar with how that works, go and look it up. I'm not going to talk about the webinar now. But suffice to say, you can do things like say, well, let's configure a class override that will apply generically to all web tests. But for this particular app, it should actually have these tests, and SCOM is smart enough to work it out and get it right in most cases. Generally, the more specific your override target is, that's the one that will actually win out and apply. So yeah, a bit of homework there if you're thinking, oh yeah, I could see use cases for all 4 of those. Yeah, I won't talk about that now. But suffice to say, it's very, very customizable. So with that, I'm going to take a break for a second and let Adam talk about some of the monitoring that we do here at Squared Up.
Yeah, thanks, Matthew. So monitoring sort of these 3 sites I thought was the best things to talk about, the things most of our customers and webinar watchers will have seen. Mm-hmm. So support.squaredup.com, we recently changed our hosting platform, and the platform will now only supports TLS 1.2, which is understandable for security reasons. So again, we wanted to make a tweak to force that. For download.squaredup.com, again, as our customers will know, we push maintenance releases every couple of weeks. So there are regular changes to that site, and every time we push a change, the site has to rebuild. And so we want the test to be a bit more flexible and not to immediately alert that the site's down. Otherwise, we'd have to start doing things like maintenance mode. So in this case, we just want the tests to allow a number of failures. And for squaredup.com, which is obviously our primary company website, it's critical. So we monitor this externally, as well as using our EA model. We also use Pingdom to monitor this as a sort of third-party source from all around the world.
Very cool. So the middle case there with squaredup.com, download, sorry. But that aggregation is quite a common ask. Actually, I've seen on support, and people are saying, why aren't we doing that out of the box? And the answer, honestly, is just that there's lots of different ways of cutting that.
Yeah, exactly.
Like, do you want to have an aggregation in the sense of, like, as long as one test succeeds, it's fine? Do you want to have, actually, we want to have at least like 2 of 4 tests have to pass? Do you want it to have a back-off interval? Do you want it to wait between each reattempt? All that kind of thing. So we've kind of left all of that out. I left that kind of up to you guys to specify using these overrides. Also, like you were saying, we use Pingdom for the squaredup.com monitoring. Yeah. I guess replace with alert site or
exactly.
Whatever
any external tool. In this case, we're using Pingdom because it's well priced and it has a pretty nice to use API, so very easy to bring data into SquareDup.
There you go. Adam recommends. Okay, so that's sort of some of the different sites that we're monitoring with our EAs, and each of these has its own sort of little scenario where we've actually customized the behavior of this. So let's have a look at that. So the first demo I want to show here is just actually achieving the top 2. So overriding the default script to use TLS 1.2 rather than trying to connect with the .NET's default, which depending on your OS could be TLS 1. Or in the case of the second one, overriding that sort of default behavior and saying, actually, this is what you want to have for this particular app. Let's edit failed a few times. It's not as important. We'd rather have that green and red actually be quite generous so that when it is red, we know it's really down. So I'm going to jump over to Skype a second. So if I go back here to my status, and I go into my, who are we starting with? We're starting with the knowledge base. So knowledge base, if I go into availability here, what you're going to see is this has been configured using a simple URL monitor check, and it's been configured for a group that has 5 servers in it. So each of these 5 is actually doing the monitoring here, and you can see an aggregation of this at the bottom. Now, when we initially set this up, the first thing that immediately happened was we got an alert from all of these saying it couldn't communicate with the URL that we configured because the TLS version wasn't compatible. So we have to change this. Now, let me jump over to SCOM and actually show you where all this lives. So, stay just when the SCOM console comes out. If you go to authoring and monitors, and then hit change scope at the top and change it, search for enterprise application availability monitoring, you'll get a whole bunch of classes up here. And you can see if you add test, custom, TCP, and web, these are the 3 test classes that our watchers were running. And if you look there, there's a monitor target in each, which is the monitor that's actually running the test. If I click on this and say override summary, you'll see that this monitor has been overridden twice. It's had the script changed once for the downloads availability monitors and once for the support site. So if I click on that a second here, you can see just like a typical monitor in SCOM. Make this a bit bigger. Good old SCOM console. We've actually exposed a whole bunch of different values. So we've got the response time threshold. So how quickly the URL test has to come back before it's considered healthy. So I could override that if I wanted to independently, or I could override the configuration blob, which contains the URL and everything else that's passed into it. But what I actually want to override here is the script. Now, annoyingly, in the SCOM console here, this override value will actually let you see the whole script, which as you can see is written on one long line, not helpful. But when you try and paste it in here, it strips all the new lines, which is an issue. So what I've written for you guys is a little PowerShell script sample that you can use on our GitHub to actually override this and put the right value in. You can also do this if you want to via using MP authoring. So you can just create a override for that management pack, export the MP, update the value to actually be the script value that you want, and re-import again. That also works fine too. But if you don't want to mess around with XML files, this is probably a slightly easier way of doing it. The scripts of GitHub, basically what it does is you point it at a script file that you want to replace the default monitoring with that one, point it at a group or an EA, and then it will create an override applied to that group or EA with that script. So it's pretty simple. So I won't labor the point too much there, but basically it goes into the management pack the EA is in and adds that as an override, which is the override you were seeing in the SCOM console just now. So the actual functionality we have, this here is the default web test script. So whenever you guys configure an EA and use the simple URL test, this PowerShell here is actually the one that you are running. And all I've done is taken the default script and I've added at the top of that this statement here in PowerShell that basically forces it to use TLS 1.2. Now, if you're asking where did I get this script from, how did I know that was the case? Well, through the power of open source, you can actually go onto our GitHub, go to the Squared Up EAM library management pack, and actually see these scripts and these tests that we run. So if I go up here into types, web, scripts, web test. There you go. There's our web test script. So as you can see, it's actually quite a simple PowerShell script. It's just using invoke web request with the URL that you gave us, using the default credentials. It then tests the response code, tests the content matching, and then builds a sensible description based on that. So if you want to customize behaviors like security protocols that's used, proxy settings, if you want to change the way it aggregates or builds the message up, all of that stuff, you just change the script. And as long as the script at the end returns a sensible object result, like it does here, with a success statement and also an alert description, we'll do the rest. So it's really, really easy to actually customize this stuff, right? So that's the TLS script. The other example I had was the aggregation. So if I go over here to my other script, this script here is the same thing effectively, but it has a while loop at the front. So the idea here for downloads, as Adam was saying, is that we don't want to fail if just one request dies, right? And that could be a transient issue. So instead what we do is we loop through 3 attempts. Now I haven't put this up on GitHub, this sample, because this is really, really raw and specialized to our example. We, for example, don't want a back off interval. We just fire 3 requests at it and one of those 3 requests must succeed. So if we have like a period of downtime where it's like, oh, it takes, if consistently we lose 3 packets almost immediately, we flag that as an issue. If you want to say, actually, when it's down, give it 5 seconds and then try again, you need to make that change in your script. So that's why I haven't put this up. I don't want you just to download and put this into your environment. This sort of aggregation really should be the kind of thing you think about as an organization and decide as a standard, like, what are we going to have? Because it can be a bit misleading otherwise if you've got a whole portal of apps where some of them use this sort of feature, some of them don't. Some are very generous, some of them aren't. So if you can, try and have a baseline in your organization and then only customize that for when it really makes sense for that particular app. Otherwise, it can be hard to kind of understand whether that red is just an up-down sort of issue, a transient issue, whether it's actually something that's real. Anyway, as I said, you can customize the script as much as you like. So you can include all sorts of bits and pieces here, go crazy. The point is, if you run that script then and put that into SCOM, this test script is now what's being run instead. It's very, very powerful. Okay, so I kind of alluded to this already slightly. If we go, or actually one more thing before I do that, just to also prove the point, if I go back into Squared Up, if I actually drill down, I don't know if you guys knew this, but if you drill down into one of these tests and you go to monitor entity and find the monitor, you can actually see that what we've done here. There you go, on the monitor perspective, this is true not just of EAs, but of all objects inside SCOM. There's a perspective that's configured on monitors, and it actually shows you the configuration of the monitor, its state change events. As you can see, we've had some issues on this site recently. And it actually shows you the default script and also what it's been overridden to here. So you can, for each particular EA, go and have a look here easily in the UI and see what the availability test actually is doing, which is kind of handy if you can read PowerShell sort of in this format. I'd probably copy and paste that into Notepad++ or inside Visual Studio Code if I were you. Okay, so that was a very quick demo, walkthrough of sort of making these simple tweaks. So from us, a couple of recommendations. Because you can override all of them, but here is some guidance we sort of found between what's the difference between overriding like the web test and actually using the custom PowerShell availability, things like that. Okay, first thing is, please do not use overrides to insert sensitive credentials. Use the run as profiles in SCOM for this instead. If you use an override as a way of injecting credentials, everyone who is advanced operator or higher and has that test object in scope will be able to see all of that data. So if you inject a password that way, you are exposing that password. So please don't do that. If you need to send passwords and credentials into one of our tests, use the runners profiles. If I jump back to SCOM very quickly, we're going to have a webinar, a V4 training webinar next week on this. But very quickly, if you go into administration and under runners profiles, we've actually configured a runners profile for each of those test types, so you can use that to bind what identity the script runs under. So if I can do that before I've got some loads. So if you get back in here, enterprise, there we go. So you've got one for each of those. And if I jump to say the here, you'll see I've bound for a particular availability monitors group the Pingdom API keys. So we talk about Pingdom in a bit, communicating with that. That's how we're sending credentials into the script for that. So make sure you use the runners profiles for that stuff. The second sort of thing I wanted to talk about was that really overriding the TCP and web test scripts is designed for you to tweak those simple tests either as a sort of management group wide tweak to modify that behavior for people who aren't technical. So if you have like application owners or people who just have a lot of other stuff on their plate and all they want to do is configure a simple test using the UI and then move on with their lives, go back to what they were doing, they don't want to write their own script. So you can, as an organization, say, right, we're going to give all of our web tests, best of 4, and they'll take 10 seconds, and we'll override these locations that we're going to give the users a chance to pick from with the most appropriate, like internet endpoint, internet proxy for them. Or what you can do is you can make those small behavioral tweaks for certain apps or locations, sort of on a very rare basis, where again, it's like, actually, all you want is a URL test, but you just need to change like the proxy it uses or whether it uses basic auth or not, that kind of thing. In which case, again, a simple override of that is fine. For everything else, if you've got like a team who are deeply technical, they've got lots of scripting and lots of advanced things they want to do with it, don't use this sort of feature for that. It's going to be really annoying to manage those changes constantly. Like, seeing it in the override window is not pleasant. Use the custom PowerShell test type. That's what it's there for. Or, as I said, use the existing monitoring feature to use another management pack or an integration you've already built. Use the monitoring for that instead, and integrate that into your EA via that existing monitoring option.
I think
test type.
A nice sort of simple summary would just be use overrides if you want to tweak the functionality that's already there, and use custom PowerShell if you want to do something brand new, something that we don't already provide. Mm-hmm. Otherwise, you just end up in a sort of minefield of overrides that end up causing more issues than you're trying to fix.
Absolutely. Thank you. So that's sort of our best practice there. Now, I keep talking about custom PowerShell. Let's actually deep dive into that. So this is the most powerful option. It is EAM Plus only. But this option is going to let you specify any PowerShell script you like, and then actually test your app using that. So this is our sort of full power test, whatever you like. Do full transactions, walk through multiple steps, hit different APIs, do true end-to-end monitoring if you want to.
Load a fat client on a test server, log into it with Active Directory credentials, all that kind of stuff.
Yep, we've got someone internally playing around with using Selenium with PowerShell, and again, doing a sort of full walkthrough there. So there's all sorts of cool stuff you can do with this. So some of you may have seen this before if you were involved in our sort of TP program, or I can't remember if Richard actually showed this on the release webinar or not, but if he didn't, you might to see how we do this now. So Adam has been talking already about how we use Pingdom for squareup.com. So Pingdom is testing it from multiple different locations around the globe, and measuring that response time from multiple different places around the globe. So what we've done is we can use the PowerShell monitoring on this to aggregate that result and say, we will use the worst response time from all those locations as the guiding metric for whether it's available or not. And we'll also how well it's performing, and then we'll also make sure that it's available in all those locations. So if it fails if Pingdom detects it fails from any of those, or it's running slow on any of those, we should get an alert listing what's happening with that.
Exactly.
Okay, so in here I went availability, turned it on, chose custom PowerShell, and then I have pasted in this script basically. Now this PowerShell script works perfectly fine, other than the credentials block at the top, outside of Squared Up. So my first recommendation when you're doing this is write a script that tests the thing. Forget like SCOM and Squared Up and everything else for a minute. Just write a script that does the test that you need. Test that. When you're happy with it, then you're ready to try and paste it in here. The only thing you don't have to worry it here, unlike a typical SCOM script, about like management pack replacement parameters or using the SCOM API or any of that sort of stuff. Your API interface basically is you have to return an object that we can make sense of. So you can just return a true/false Boolean value. And if you do, we'll assume that true means it's the test succeeded and false means it's bad. Or you can throw an exception. If you throw an unhandled exception in your script, we'll assume the test failed. Otherwise, if you return nothing, we'll just assume it passed. Or if you want to get fancy, as we have here, you can return a object that's got a success property on it, and we'll use that for determining the success. And then we can read out things like the alert severity level, so you can have warning or critical, depending on what happened in this script. We'll read out the alert description, the response time that we should measure against, all that kind of stuff. And we do that response time measurement as well for you. So all you have to do is return the value, and then we have the block of code that checks to make sure it's within the threshold that was specified. So I've got the boilerplates taken away for you. I want to run through the script very quickly, just to give you an example of some of the things you can do in it when you come to writing these scripts. The first thing is Pingdom uses basic auth to connect to its API, as I imagine a lot of sites and APIs tend to do via HTTPS. So at the top here, I've constructed just a little hash table that's got some headers that I'm going to send as part of my web request, just to make it easy. Now, here's the key point. Normally, to create a basic auth header, you may know this already, but you have to base 64 up your username and password. We've done that for you already. So when you specify in your run as profile the basic credentials that get passed in, we have already, before it gets passed into this script, taken that, base64 encoded it for you, and made it available on an object called $credentials. And if you go .username, there's the username, .password is the password, .basicauth has the base64 version for it, and we have a secure string and PS credential type on there as well. So again, all the boilerplate, you should usually do that sort of stuff in your scripts, we've taken care of. And also we're taking in the app key. This is coming from $config, which is a configuration block that you can specify down here when you run your script. And again, this field is overridable on a per test group watcher basis. So if you want to do something like, say, I've got two different sites, test it from both sites, but they have different proxies. I don't want the test for one of them coming across the corporate WAN to then go out the same endpoint. It will always read slower that way and give you a false sense of what's going on. You could put the proxy inside this configuration JSON, use one script for both, and then just override on the second site the configuration blob to say, actually, this is the proxy name you should use, or this is the name that you should try and resolve for the app's name, instead, something like that. Okay, so then I've hard baked the URL. I don't have to. I could put that in the configuration block. It's my choice, but I wasn't going to vary it, so I didn't feel the need to do so. And it goes and does an invoke REST method because this is a REST API against Pingdom. There's a config tags being sent in here. Now, this is something that you did, Adam, isn't it, to try and make sort of Pingdom a bit more usable?
Yeah, I mean, when we started using Pingdom before V4, so without enterprise applications, we were using perspectives on top of our Veda-mapped sales app. Mm-hmm. And in order to match, I mean, it's one of the pitfalls when you use external data with SCOM is you need some common denominator in order to use perspectives. So you need to be able to pass something from SCOM through your API query to match something in your endpoint. So in this case, we took the ID of the Veda app from V3 and applied it as a tag in Pingdom, so that way we could truly use perspectives. Mm-hmm. So when you looked at the sales app, it would pass the SCOM ID of the sales app. Pingdom had it applied as a tag, and therefore it would pull back the results for the test on that particular object. Mm.
So you could use anything you like here. You could use like your CMDBs.
Yeah, exactly.
I mean, applications.
The key is just to have something common that you can query that you can query from your script or from your perspective or however you're going to pull data back in. Just as long as there is something common. Yeah, if you're just making a dashboard, you can specify everything statically, of course. But if you're looking at something like perspectives or dynamic tests like this, you need some common denominator.
Yeah, it's worth noting. Like if we just queried for every single check in Pingdom, it'd be a lot of noise, right? So it wouldn't be worth it. Okay, so that basically comes back with a response that is a nice rich object that's full of all the different data from Pingdom, because we used invoke REST method. And then basically I have some logic here in the script that then tests to make sure there was a response. And then for every check, so every location, that's what a check is in their API, pull out the name, the last time it tested, and whether it worked or not, what the response time is. And then I have my own custom aggregation. So this is where I actually build up a really cool little, I'm quite proud of this, cool little description for the alert. So it actually says, like, the following availability tests have failed, and then actually lists all of the regions that had an issue, not just the main one that triggered it, and also their response times. So the alert that I get when I look at this EA, if I'm a support staff member and I come to the sales if I come to script.com, sorry, and I click on the alert when it's showing as red, I know where in the world it's failing, how badly it's failing, and I have all the information I need there to actually escalate this properly, rather than having that sort of typical description that says the response time was 400 milliseconds over. That's not very helpful, right? Exactly. So it really behooves you, if you can, to make that description as detailed as possible. And I mean, this is just a very simple like loop, right, where it just goes and builds up a string. But you can imagine that could be quite complicated if you wanted it to be. And the final key point is that it creates that object that it's going to write out. So a custom PS object that has the success field. So that's the result of all the tests. So if any one of the tests failed, it fails. And then it has the worst response time. So take all the checks, expand their response times, use measure object to find the largest one, and that's the maximum value that's passed through. And then also the description as well as that built-up description, and returns that out here. So you could do whatever aggregation you like there. You could say, actually, it's the average of all the test types amongst all those three, or it's the worst time, except the US location specifically also gets a bit more priority. Whatever you want to do there. So that's the wildest of your oyster.
I mean, even like common SCOM health rollups, the health state of the best member, the health state of the worst member, that kind of thing. If you if you've got 4 tests running and you want only one of them to succeed, or you only need one to succeed to say it's healthy, you can do all that.
And then, this JSON block here passes in things that I might want to vary on a per app basis, or I just don't want to bake directly into the script. So as Adam said, there's my response threshold, so the time the sites have to respond. And I've also passed in the tags and the app key as well. But actually, realistically, those could be baked into the script. Just an example of, you can have as much data here as you like as a piece of JSON.
Just as a sort of like general, general best practice around this as well. Whenever you're talking about defining response times, it's always worth doing more than just sort of sticking your finger in the air and guessing. So in the context of internal apps, maybe to you a 5-second response time is really terrible because you develop really like nice, quick, fast web apps. But maybe if you're some internal app, 10 seconds is actually what it takes. So it is worth always talking to somebody with expertise, so either the app developer or a user group, the app owner, whatever, and actually building these tests to really represent how the app should perform and not just sort of a guess.
Yep, and also likewise, it should be reflective of your SLA with the business as well, right?
Exactly.
Like this is an example here. This script.com one's been configured. I've lowered it down to like 3 seconds, and as you can see, there's actually a fair number of spikes here across the past week. Where there's some quite large ones in some cases, but there's a fair number of spikes here where it just takes slightly more than 3 or 4 seconds. And actually, realistically speaking, that's fine for a site that loads. So and Adam said, don't have a site that's flip-flopping constantly. If it's doing this all the time and everyone's looking at it and no one's complaining, it shouldn't be. Up this thing so that when it goes red, it's meaningful. Don't just stick your finger in the air.
Exactly. I mean, this exercise might also be a nice opportunity to sort of highlight those apps that people are just sort of complacent about, it takes 10 seconds to log into whatever. Maybe this is a nice opportunity to actually highlight things that should be better, should be reworked, and then properly monitored.
Absolutely. So with that, if I go back to the script, I've got 3 tabs open. There we go. So that's basically it at that point, and I pick my watches. Now, a note with this one, another reason I went back into that screen, I've chosen the same script.com watches group here, which as I said has a bunch of configurations. Because this test is actually hitting Pingdom and asking Pingdom what all of its watches are doing, it's kind of pointless me querying from all these different locations, because in effect what we're doing is we're saying from these five locations, what does Pingdom think?
Yeah, exactly.
So what I would say is, if you've got tests like this where you're hitting out a different app, rather than using boxes from all around your environment, just put 2 in there. The reason I say 2 is because if you put 1 in there and it fails, it might actually be because there's a problem with that local test client. So it kind of isolates it if you pick like 2 management servers that aren't in the same LAN or something. Ideally, they'll go red or green at the same time at that point. And if they're not, if one of them's going red, and you can see here they're all doing it at the same time, but if one of them kept going red and one of them didn't, well, that probably actually means is that box is having some intermittent internet connectivity, because the way the test still works, remember, is if it can't talk to Pingdom at all, it counts the site being down. You might want to modify your script so that that's not the case, and actually if it can't talk to it, it doesn't return any health state at all, or just considers to always be green. I don't know, again, that's up to you as an organization to decide whether you want to have sort of red first or green first kind of behavior on that one. But like, let's make it more than 1. And what you could also do as well is you can go and use an override in SCOM on the roll-up monitor that rolls up these tests for this EA, and you can configure it to change it from worst health to best health. So that way, if you do have 2 locations, you can say, look, both of these locations are talking to Pingdom and asking what Pingdom thinks of all of this. As long as one of them works and one of them is happy, that means Pingdom is happy because they're both pulling the same test data. Don't raise an error. So again, that's a way of you customizing sort of the behavior there.
It's probably just worth highlighting as well that this is, I'm right in saying, Matthew, that this is basically any server with an agent that can run a task can become a watcher.
Yes.
So, if you currently use, for example, GSM, which is sort of disappearing, deploying boxes in Azure in 4 different regions is, low spec machines, low cost machines. Stick a SCOM agent on them. There you've got your replacement for GSM.
Yep, exactly. And you could load those things up. You don't need to have specific watcher nodes for every single application. Like I said, it isolates them perfectly happily. So you can have, this management server here is running tons of different tests. So you can have, these are our dedicated, like I'm saying, test boxes. Or you can reuse an existing computer infrastructure you have.
Exactly right.
Just please don't pick something that's in your data center. Try and pick something that's actually reflective of where end users are if you can. Just
outside in wherever possible.
Yeah, absolutely. And likewise with the URLs, right? Don't have the URL point at a specific server's name. There's value in doing that in SCOM. Don't get me wrong. Definitely go and configure monitoring that says, is this server working? But this feature is supposed to be pointing at what the end users use. So if end user are hitting a load balancer, this test should hit that load balancer. And then you can go and configure separate monitoring as part of, say, your map or as other dashboards that target each individual server's address that the load balancer is pointing to. But make sure you can actually do it from as end user facing as possible.
Yeah, our sales app that we commonly bring out for demos is a good sort of highlight of that. So we have an F5 load balancer in Azure. That's what you hit when you go to sales.squareup.com. And then through the map and dependencies, we're bringing in the web tier, the app tier, the SQL tier, the Oracle tier. And obviously we're able to then bring all the alerts together into a single place. So you're running sort of real user-specific, sort of user-focused application monitoring, but you can also then keep in your typical sort of old-school infrastructure monitoring and alerting through SCOM.
The last thing I wanted to show you, just around this, is to point out very quickly that availability monitoring can be used just by itself. So if you notice for the squareup.com EA, the map and the dependencies are empty, because we don't actually have those components inside SCOM in this environment. So they're all up sort of on a managed platform anyway, so we don't have anything we can monitor at this time. So for now, we have just put this up until we developed a management pack for it for the site. We actually just put this as an availability only EA, but that still means we can create these consistent dashboards here where we can actually model this along with the rest of our other stuff where we do actually have internal monitoring. I'm not going to go into our some of these apps, but if I go to our payment processing app, for example, we have modeled that. There's components in there that are giving the map health. So you can get started today with this sort of thing, give the business this top level dashboard and worry about the actual map and things later on. But the availability monitoring is really the valuable sort of first part of this, because just being able to give your business a consistent portal where you can say, these are our enterprise services and whether they're up or working or not, that's actually has a huge amount of value in and of itself. Okay, so I think in a rarity, I might actually finish on time, which is a little bit scary, so I'm wondering if I've left something out. With that, I'm going to come to the resources slide. So if you like this webinar, or if you hated it, if you've got like us to cover something separate, or you've got a question that's been burning on your mind ever since we released V4, head over to our community site, community.squareup.com. Raise a question there, let us know what you'd like to cover. In the meantime, you'll probably get an answer from one of our amazing community members or the SquaredUp staffers that lurk there within. If not, then we'll always highlight existing interesting answers, or maybe look at a topic and say, no one's got a good answer for this. Let's go and dive in and do a coffee break on it. So that is a great place to give us feedback. We are definitely always watching.
Prizes if you can find Matthew's community answers pseudonym.
No, there's no prizes. Don't don't say that. Okay, so if you want to sign up for future coffee breaks, you can head to squareup.com/coffee-break-series. Where we post blog entries, and also there's the schedule. So you can put your details in there, hit sign up, and then you can come on these webinars live with everyone else and ask questions in the chat and get sort of feedback as you go along with the webinar. So definitely, if you're watching this on YouTube right now, definitely get involved. Come and join us on the coffee breaks. Our recordings and slides are published via our blog, .com/blog. And there's a whole bunch of good content there, not just as coffee breaks, so it's well worth checking out. We've got an APM series running at the moment that's quite popular, so definitely go and have a look at the stuff that's showing up there. And the YouTube playlist for this series is available as well, so you can sit back and watch all. I think this is the 46th coffee break now, so you can watch just hours and hours of great content on enterprise monitoring, squared up, SCOM, customer case studies, our experiences at events, all sorts of other cool stuff. So definitely worth checking that out if this is your first coffee break you've ever been on. Okay, now as always, myself, Adam, and the engineering team are going to stick around and answer questions. So if you've got any questions from EAs or the topic today, or just generally squared up and SCOM, please feel free to put them into the chat, and we'll try and tie this off now. If you haven't got anything, thank you very much for joining us. Thank you, Adam.
Thank you very much.
And we'll talk to you next month, guys.